So this is page 4 of Spiral Kinematics Activities, wherein we have motion diagrams and we're supposed to identify the algebraic sign of position, velocity, and acceleration. And so the way that we determine sign is both by the location of the that arrow, which is the origin, and the dot here on the left-hand side of it is the actual origin itself, and then the direction of the arrow indicates what's the positive direction. So you can either do this by going through the position for each of the 3 spots and then go to velocity and then go to acceleration, or you can choose spot 1 and do position, velocity, and acceleration. So I'll just do both ways with the 2 that I have showing right in here. So since this is the point at which the 0 is, that makes position 1 a negative and makes positions 2 and 3 positive. Now, in terms of velocity, it doesn't matter where you are. What matters is the direction that you are going, and the direction that is positive in this one is to the right. And since the object is moving to the right in all 3 cases, that means that the velocity is positive in each of the 3 cases. Now, in terms of acceleration, what you have to do is to identify, okay, for this initial portion here, for positions 1 and 2, it is speeding up to the right, so that means that the acceleration is to the right, and that appears to be the case all the way up to about that point, up to point 3. And so since the acceleration is to the right and positive is to the right, that positions 1 and 2 have positive acceleration, whereas beginning at 3, you can see that the arrows are getting shorter, so that must mean that they're slowing down, which means that the acceleration at this point is to the left, which is the negative direction. Now for item B here on page 4, well, in terms of the description, that I won't write it out, but it could be something like a car speeding up from a stoplight and then slowing down at the next stoplight. Okay, so if you look for item B, that the motion is in fact the same as A. What is different is the origin, that not the location of the origin, but what is positive, because in this case to the left is positive. And so keeping that all in mind, I'll go ahead and while I'm in the neighborhood, I know that this is the case. And so if we look that since the origin is right here, anything to the left of that is positive because of the direction of the origin arrow, and everything that's on the right-hand side of that would be negative, but I'll do this beginning with position and then velocity and acceleration at point 1. So the position in point 1 is positive. I am moving to the right, but to the left is the positive direction, so that means that my velocity is negative. And since the acceleration is to the right, it is negative as well. When it comes to point 2, that now I am on the opposite side of the origin, so I am in a negative position, and again my velocity is opposite the direction of the positive, so that means that it is negative, as well as the acceleration. And finally, the position point 3 is negative, velocity is negative, but now the acceleration is to the left, which is the positive direction in this case, so there I have a positive. So what you see before you here is this is items A and B from page 5 of the spirokinematics activities. And so what we have, like the last one I showed, it's the same motion just with differing origins. And so one of the things that I like to do whenever I have motion diagrams is to always make sure that I show the acceleration on the motion diagram, and the acceleration is to the left the entire time, and so that's why on the upper track, that since I'm moving in the direction opposite of the acceleration, I slow down, whereas on the bottom track the acceleration is in the same direction that I'm moving, so I have positive acceleration. So having said that, here is the origin. Everything to the right of that is positive, and to the right in terms of location, and then to the right is positive in terms of things like velocity and acceleration. And so looking at that, point 1 on the left-hand side, so that's a negative position, whereas 2 and 3 are both positive. My velocity at point 1 is in the same direction as the positive, so that would be a positive velocity. Try to make a plus sign. At 2, the velocity is actually 0. That's a circle with a slash through it, even though on this tiny screen with this stylus it doesn't look that way. Whereas point 3, I'm now moving to the left, so that's a negative velocity. Since the acceleration stays the same the entire time, and the acceleration is to the left and positive is defined as being to the right, that the acceleration is negative in all 3 cases. Jumping down to B, that point 1 is clearly position negative. Its velocity is positive because it's in the same direction as what we've defined as positive to the right, and the acceleration is to the left, so that means it's a negative acceleration. Position 2, my position is at the origin, so it is 0. My velocity is 0, but just because my velocity is 0 doesn't mean my acceleration is 0, because the instant before point 2 and the instant after I actually am moving, and so, or whatever this object is moving, so therefore there is an acceleration and it stays negative. At point 3, I have a negative position, I have a negative velocity, and I have a negative acceleration. In terms of a description, anytime I see something like this, I oftentimes think of throwing something up in the air, and so that's one way to do it. Or you can be rolling backwards in your car, transitioning from reverse to forward, where you would roll to a stop and then start going the other direction. So those are possibilities.